Ever thought about a master's degree to advance your career as a software developer? The UC Irvine 16-month professionally oriented Master of Software Engineering program is made for you. Taught by experts in the field, the program combines hands-on experiences in fundamentals and latest trends with professional development for successful careers after graduation. Hurry, applications for fall 2019 are due December 15th. Visit mse.ics.uci.edu to learn more and start your application today. This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software. DigitalOcean is the easiest cloud platform to deploy, manage, and scale applications of any size, removing infrastructure friction and providing predictability so developers and their teams can deploy faster and focus on building software that customers love. With thousands of in-depth tutorials and an active community, we provide the support you need. DigitalOcean stands out of the crowd due to its simplicity and high performance with no billing surprises. Try DigitalOcean for free by getting a $100 infrastructure credit at do.co/SERadio.
Hello, this is Kishore Bhatia for Software Engineering Radio. Today's episode is about the Ethereum ecosystem and decentralized computing infrastructure and applications with John Crain. John is the founder of Pixura and SuperRare, the platform for rare digital native collectible assets on Ethereum. John was previously at Consensus, working on Ethereum-based products, followed by his role as the head of product at BlockApps, where he helped build and launch an Ethereum Smart Contract developer platform. Welcome to Software Engineering Radio, John.
Thanks for having me, Kishore.
Today we are going to talk about Ethereum and the Ethereum ecosystem that we have seen evolve in the last couple of years for a decentralized computing platform. We'll also overview different comparable technologies that exist today and that are evolving in the space. Ethereum also has the concept of smart contracts. So we'll run through some examples of how smart contracts have evolved in the Ethereum ecosystem. There is also the concept of applications that are developed on Ethereum platform, known as decentralized apps. So also going through those examples would be helpful with John here, who has experience developing them and deploying them. And then we'll lastly cover the developer ecosystem to actually get to dApps and writing smart contracts on Ethereum. So John, we'll dive into the history of Ethereum and also go through where we are today and why is this relevant in computing. Starting with, what is Ethereum?
Sure. So at its core, Ethereum is an open source software platform that's based on blockchain technology. And sort of what's special about Ethereum is it enables developers to build and deploy decentralized applications. And so what that means is Ethereum's a little bit different from other sort of blockchain platforms in that you can actually embed parts of the application into the blockchain itself. And this is pretty interesting because, sort of the data that gets, updated by those pieces of code living in the blockchain, nobody's actually in control of them. So once you, sort of like write up your script and deploy it to the chain, that code is it's sitting out there for anybody to use, and you're not going to be able to update it, which is it's sort of a different paradigm than we're used to. We're really used to this sort of CI environment where it's like, oh, there's a bug, let's just push a commit to master. We'll just go ahead and update the whole app. So it's an interesting paradigm to program in.
That's interesting. You mentioned something about embedding code within the blockchain. I do want to double click on that and go deep when we come into the components of the ecosystem. But just to get into the details of why now and why is it that we need it in the current ecosystem. So why is Ethereum needed?
Yeah, great question. Probably lots of the listeners are somewhat up to date on some of the recent sort of Cambridge Analytica scandal with Facebook, data ownership and privacy and things like that. And so basically what Ethereum allows by sort of, having this totally decentralized, aspect to it is, users and builders of these apps, they can sort of place things and control the user. For example, just pieces of data that the user has control on the chain. Ethereum sort of gives developers the tools, to build applications. And then these applications give users the tools to sort of have a much greater control over just their identity and data in relation to the application. So, there's no one central authority. Sort of all the data is out there. The data can be encrypted or not. This is sort of like up to the developers themselves. But we now have sort of a totally open and secure database for developers to leverage. And at the end of the day, this is a huge benefit to consumers because these big data silos and data aggregators, they're pretty vulnerable to misuse of terms of service, as we saw with Cambridge Analytica, misuse and sort of vulnerabilities for as far as people hacking into systems. Last year, we had that huge data breach with Equifax, and it seems to me like we're learning that we sort of just need better standards, and Ethereum is a tool that kind of facilitates an easy way to implement some of these improvements.
And there are commoditized, cloud platforms today to develop a lot of applications that are distributed in nature. How is Ethereum different in that sense? And you mentioned the word decentralized, so I wanted to just capture for the audience the difference too.
Sure. So Ethereum's a decentralized, smart contract platform. So each, node in the network, that's sort of, mining, contributing to the security of the network, has a copy of all of the smart contract data. So they're sort of ensuring that, no one is sort of cheating or manipulating that data. You as a user are in control of your keys. So if you have an Ethereum account and, you want to interact with a smart contract or decentralized application, only you are going to be able to do that. Only the person with the private key can go update something in the application that key has access to. So you now have this greatly improved level of security that's sort of just inherent in the platform. Postgres is a really good database, but there's not sort of this level of public and private key encryption sort of like baked into the core of it. You can add really good user level permissions and all sorts of security features on top. But really Ethereum has all of those things sort of just like inherently built into the system.
I see. I do want to get into the details of the components later in the show. And it's amazing that you mentioned something around the decentralized nature, the inbuilt security on how data is stored within each node, and the fact that data is actually replicated across each node, and everything is always persisted. So you can actually do a quick audit as well. What does the ecosystem look like today with Ethereum? Is it the first one? Where are we in terms of where all the blockchain ecosystem components are?
Sure. So yeah, Ethereum definitely was not the first blockchain, but as far as smart contract platforms, it definitely was the first and has the most adoption. So just ecosystem in general, Bitcoin's sort of the OG. It's been around for a long time. There's the interesting debate between Bitcoin and Bitcoin Cash happening, but Bitcoin's still quite relevant. I wouldn't, it's probably not going to go away anytime soon. We have the Lightning Network is sort of up and running in beta, which is super interesting. And this is, an interesting step forward for payments. As far as smart contract platforms, I'd say Ethereum's definitely has the most developer adoption, and I'd say the most applications actually in production right now. That said, it's not the only platform out there. So there's also a platform called Blockstack. They're taking a slightly different approach. They have a concept of like virtualized chains, and I think they're trying to be sort of blockchain agnostic, but they have this concept of decentralized applications. They're really working on data ownership and privacy also. I think it's not quite as decentralized in nature as Ethereum, and there's pros and cons to this. So it's sort of like how interested are you in the decentralized security in the nature of the application? And I think a number of the other ones are similar. So EOS is not actually they don't have a working production blockchain, but they are working on building smart contract solutions. They have sort of this federated node, delegated proof of stake, lots of interesting sort of buzzwords around how consensus is achieved. But essentially, some of the sort of like higher throughput blockchains have the pro is that they achieve consensus really fast. The con would be that consensus is achieved in a more centralized manner. So, some people might be critical of how they're doing that.
Right. And in terms of the trends that have happened over, the last 20, 30 years in computing, and also like recently within the post-internet era, what is driving this innovation? And also we want to like get into the aspects of what is driving adoption. So let's just begin with what is driving the innovation like Ethereum in the community.
Sure. I heard a concept recently that I'd never heard this term before, but sort of it was like the distributed web ice age. We've had a lot of these peer-to-peer technologies, at our fingertips for a while, and they maybe just weren't sort of brought together and, productized and, in a way that was friendly for a developer or consumer to use. So, a lot of these concepts have been around. We have distributed file sharing, all sorts of different distributed applications. But there's sort of been this resurgence in, research in the area and, just sort of general interest. I'm sure a huge part of it is due to the speculative nature, of a lot of these, companies and groups issuing tokens. But I think ultimately it's all for the best, because there are some pretty, there's some pretty critical problems with how we sort of manage identity on the internet, managing data ownership. We still have some pretty big problems that require, pretty interesting solutions. And I think a lot of the innovation and drive is coming from, people acknowledging that these are sort of pretty serious problems that need to be tackled.
Gotcha. And we'll get into the details of community, in a bit. But in terms of adoption, what have you seen in the recent years? We've definitely seen a lot of hype on, the beginning of the blockchain hype cycle. 2015, 2016. You mentioned, rightly about the speculative nature of most of these, with tokens coming into picture. But there's definitely a lot of technology work that has gone in to push these things towards general public use. What is the kind of adoption that you have seen recently?
As far as adoption, do you mean like from a development standpoint, or for like more like consumer facing applications?
Yeah, good question. I think let's begin with consumer facing applications, and then we'll do a deep dive as we get into ecosystem.
Sure. So yeah, I'd say there's been a lot of interesting developments in the consumer application area. One of the interesting things is I think we're still in a little bit of an infrastructure building phase. So as far as the really good consumer applications, there's this idea of like a dApp browser, or decentralized app browsers, and there's sort of an interesting combination of like just a regular web browser, but also kind of a chat application. And then also a key management solution. So, a lot of these decentralized applications, and, one of the interesting features is that you're the only person who can sign a message from your account. And so you sort of need to have this key management layer and message signing feature kind of built into the browser natively. There's a pretty good Chrome plugin for doing this. It's called MetaMask. It's probably, one of the most used, I'd say it's not really a consumer application, but it's kind of like a consumer tool. And then there's some pretty good mobile key signing dApp browsers. One of them is called Toshi. It's put out by Coinbase. Another really great one is a Trust Wallet. That's an open source iOS and Android app. And that's I think a pretty small team out in San Francisco. So these tools, kind of coming into their maturity, have sort of allowed some of these other apps to be built on top. I'd say the most successful and kind of most used apps that are out right now are kind of these like trading applications or marketplaces. So there's a number of different token trading applications that are out there. CryptoKitties, as many of the listeners have probably heard about, almost really clogged the Ethereum network for a while. Yeah, I'd say most of the consumer apps are kind of like trading focused or, have some aspect of this token trading sort of built into the application right now.
Right. I think you're also, like you mentioned, the use of identity and data privacy on, things like the dApp browser and also the messaging and chat apps. So that's pretty interesting as to how they are evolving. Getting into the main components. So that's basically, our view of Ethereum, the ecosystem. We talked about the innovation and adoption happening. I think we wanted to also look at the architecture of what we understand Ethereum today. So, if I'm looking back at, 2014, I was actually, looking at this one world computer aspect of Ethereum. The vision, at least, was that it's basically a giant computer that is, decentralized and distributed across the world with many connected components. And that reminded me of this quote from one of the Sun co-founders, also by the name of John Gage. And he said, the network is the computer. And I feel like that's probably what is coming true with something like Ethereum, that has all these connected nodes with, a replica of each and every aspect of the ledger that has the different transactions, blocks, events, and even you mentioned code that I want to get into. So, John, let's dive deeper into the components of Ethereum, the Ethereum stack.
Sure. So all of the different components in the Ethereum stack are outlined in Ethereum's yellow paper. So this is sort of just the mathematical and technical spec that outlines everything. But at the core, Ethereum is different from blockchains like Bitcoin, in that Bitcoin has a sort of UTXO model, or unspent transaction output model. That's how they keep track of, who has which balance. Ethereum took a different approach. And on Ethereum, at the core, we have this idea of an account. So there's two different types of accounts. First, there are external accounts. And these are accounts that the private keys are controlled by, humans. And there's also internal accounts. And so these are accounts that get created when people sort of upload and create a smart contract. So these live within the system, and these can, have code attached to them, which is different. So the external accounts where, humans control the private keys, there's a no code property. So those are probably the two main differences for those different types of accounts. And so then one level up from that, we probably have sort of the state. So this is basically an instantaneous snapshot of what are, any data field or anything that's been changed in Ethereum. State is sort of the just current state of everything. So there's two different types. We have there's memory and storage. So memory state would be things that get updated during execution of a smart contract, but don't get persisted. So, this could be, potentially like a counter and a for loop or something like that. Something that we're going to, update state momentarily, but then we don't need to keep around. And storage is, if we're adding a new person to our, multi-sig wallet or something, we're going to want to keep this data around basically forever. So those are the two different types of state. And the way people update state is by, either just sending an Ether transaction, so a simple transfer, or calling a smart contract method. And with general purpose programming languages, we needed some features to kind of prevent people from, running an infinite loop and crashing the entire system. You can imagine if you're running an infinite loop on thousands of computers around the world, this is going to be pretty expensive and wasteful. And so Ethereum came up with this concept of gas. So gas is basically sort of the price you pay for each computation you'd like to perform on the network. So say you want to, update a value, it used to be 1 and now things have moved along and it's time to change it to 2. And we're going to update this value in storage. So every node in the network is going to have this updated. This is a pretty expensive operation. I think one of the most expensive things you can do in Ethereum is to update storage. And so you're going to pay the most gas to perform an operation like that. Whereas something, sort of a memory performing operation, has a much lower gas cost than a storage state update operation. So every time you make a transaction in Ethereum, if you're calling a smart contract, the system will estimate what's the gas cost going to be, how much ether do you need to provide with the transaction just to make sure it finishes executing. And so ultimately the gas is sort of solving the halting problem, where you would just cause the network to stop working sort of by like using up all the resources. And so, while I was talking about that, I was just talking about executing smart contracts. And the way this happens in Ethereum is through transactions. Pretty much everything is a transaction, whether you're just, sending somebody $5 or, you're deploying a new financial derivative. So it all works through just transactions and message passing. And basically the transaction will be built, client side, possibly in your browser, maybe on a mobile phone, or a desktop app. This will be compiled based on all the data you want to have in that message. And you'll actually sign the message with your private key before submitting it to the network. So this ensures somebody can't go in and tamper with the data that you'd like to send. And it also is pretty convenient because you could actually sign a message and then just give it to somebody else to submit to the network. So I could potentially sign a message locally on my computer, email it to you, Kishore, and then you could submit it to the network for me. And this is pretty cool. And there's some interesting use cases here where you might want to, potentially send money from a cold wallet, sort of offline storage, to a hot wallet. And you could just sign that transaction on your offline computer. And then you could put it on a USB stick and carry it over to a different computer and submit that to the network. So this is, an interesting feature of the message signing. And I guess the next level up in the stack, we have, these blocks. So the transactions get ordered in blocks. Basically, what the nodes are doing is they're sort of like mining these new blocks, is ordering transactions and then trying to tell all the other nodes of the network which is the best block that they should have. So the most recent block that exists. So the nodes are sort of accepting all these transactions, ordering them, trying to mine the block using the proof of work consensus algorithm. And then as soon as they mine this block, then they're going to go ahead and tell everybody else, gossip style, about this block that they've just discovered. And so, I just mentioned proof of work. So proof of work as a consensus algorithm is basically the nodes trying to compute a specific hash. So, statistically, it's going to be hard to kind of guess what this hash needs to be. So it's designed, based on how many nodes are on the network. They try to make it a little harder, and I think it scales up linearly with each node. They try to keep a consistent block time based on the difficulty. So the more nodes on the network, basically the harder it is going to be to actually mine one of these blocks. So, does that make sense?
Yeah, I think so every time you're saying as the chain becomes more and more heavier with more and more transactions and blocks coming in, it becomes more difficult to mine a new block.
Yeah, that's correct.
Gotcha. In terms of the account, you mentioned the account has every account has a specific account address, and like what else is within an account?
Let's see. Yeah, so there's a number of different properties on the account. You have some of the cryptographic sort of features that's slightly above my pay grade for knowing exactly how the sort of like the elliptic curve signatures work. But there's a number of different properties there to kind of ensure that nobody else is going to be sending transactions from this account. So you can have accounts have a balance. So this is sort of like the amount of ether associated with this account. So that gets used for the different gas and, just simple transaction sending that I mentioned before.
Right.
And then also some of these, different signature properties.
Gotcha. So what is the world state, like where is that maintained?
Gotcha. So each node on the network is actually going to maintain this state locally. So if you're, spinning up a new node, say you're on AWS and you want to, try mining some Ether, you can, download the software, compile it, and start running. And you're going to actually download the entire state from all the nodes you're connected to, and you're going to be maintaining your own property. So anytime a new transaction comes in that you think is going to be committed to a block, you're going to update state locally, and then tell everybody else, hey, I have this new transaction. You should also run it and update your local state.
Gotcha. Yep. So I think you mentioned something around transactions. Can you elaborate a bit more about transactions, different types? Is it always all about accounts passing Ether from one account to another, or are there different types of things going on?
Sure. So there are different types. So all the transactions are just messages to the network. So we're just telling the network, hey, I want to do something. But there's sort of two different types of things you can do. So you could do a simple send transaction. So this would be passing Ether from one account to another. So if I have an offline account and I wanted to send it to my online account connected to the internet, that's one type of transaction. Or if I'm paying you back for the pizza you bought last night, Kishore, I could just do a simple send transaction. And then the other type of transaction is when you're actually interacting with a smart contract. So if you want to, sort of do, call any smart contract on the network, you send that message sort of signifying that, like, here's this address I want to talk to. And there's a, in the transaction, there's a data field. So when you're calling a smart contract, you sort of say in the data field, I want to talk to this account, and I'm actually going to send this piece of data also that, says exactly which smart contract method you'd like to call.
And then how do you keep track of like the transactions, having them completed or, something failed? Is there some kind of a logging mechanism?
Yeah. So Ethereum has a sort of an event log system that kind of helps maintain sort of, a little bit of metadata about what's actually happening in the system. So yeah, you can, kind of pull these event logs. So as soon as you submit a transaction, you instantly get sort of a transaction receipt. Then you can kind of watch and see to make sure, either, or at least to know. So, as this is an enormous distributed system, you're not always sure your transaction's gonna, make it into a block. You don't know, which block it's going to get into. So you get a receipt, and then you can kind of pull the logs to check and see, okay, is there sort of a verification event that my transaction was actually included?
So then the concept of smart contracts, they come in and basically play within these different areas that we mentioned around blocks, transactions, message sending, right?
Yep.
So if I'm creating a new contract as a developer for the first time, and let's start with simple storage, can you go over maybe the flow of what happens in the network when a contract gets created?
Sure. So the first thing that would happen if you're a developer, you would actually sort of compile your smart contract, and you'd get two things. You'd have the ABI, the application binary interface, that kind of says, okay, here's what's in my smart contract. Here's all the different methods, variable names, and sort of data like that. And then you'd also get a chunk of bytecode. And so this is what you're actually going to upload to the network, and is what's going to basically update the storage and live there in Ethereum. So after you've compiled the smart contract, you're going to go ahead and sign a transaction saying, hey, this account would like to deploy this new smart contract to the network. Here's the bytecode of the smart contract. So here's sort of all the the business logic, and then you would submit that just like any other transaction. All the nodes, once they pick it up, are then going to store that bytecode in their state and attach it to a new account. So when you deploy a new smart contract to the network, you get a transaction receipt like, hey, we got your transaction. We know you're trying to do something. And then upon successful creation, which means that all the other nodes in the network have committed this transaction to a block, you're going to get the address of that smart contract back. And so this is what you need to then interact with the smart contract once it's uploaded.
And like going down to the machine level now, the part of the protocol that basically processes all of this, transaction work, and then also helps creating new blocks or validating them is a machine, right? Can you go down into like what is that machine like?
Sure. So the low level, of Ethereum is basically a few things. But you're sort of, so at the core, we have this, Ethereum doesn't do that much besides agree upon, which transactions are valid. So we have all these nodes on the network. They're talking to each other, communicating about new transactions that are coming in. And they're performing what we call, proof of work. And basically what this means is that each transaction that comes into a node, they're going to do a quick check to make sure, does this account have enough ether there to actually run this transaction? Has this message been signed? Has the transaction been signed by the proper account? Some simple validation. And then they're going to include it in the block they're trying to mine. As soon as they, mine this block, correctly calculate a hash within a specific range, they're going to then tell all the other machines on the network, hey, I just found the new best block. You guys should all sort of update and start mining a new block because I just found the best one. Is that what you're getting at, Kishore?
Gotcha. No, yeah, I think that's a good sequence of what's happening. And then there's this whole virtual machine concept, right? What is that?
Sure. So the virtual machine is kind of, it's similar to, any other virtual machine that, you might be running a Java virtual machine at home on your computer right now. But basically this is sort of the meta layer on top of the agreement about transactions. And the virtual machine is what processes all the smart contract code. So when somebody wants to interact with the smart contract, call a method and do something to the state, the virtual machine is where the actual execution happens. So if you're calling a method that is going to update a bunch of different properties that you have stored in a struct or an array, this execution actually takes place in the virtual machine on each computer on the network. Gotcha.
And in the way the network gets consensus, what is happening between these machines? Are they just broadcasting these messages that I found a new block, or this is my canonical chain that I'm on? What is happening in between these nodes?
Sure. So basically, all the nodes, they're competing. They're trying to find the new best block. They call it the fastest because they'd like the mining reward. So each node is basically it's sort of ingesting accounts that are transactions that are being submitted to it. It's validating these transactions and then sort of packaging them up into a block in the hopes that they'll be the first one to compute the new hash that needs to be computed. Then once whoever finds this block first kind of tells the network. And say you had two different nodes on different sides of the world basically find the new best block approximately at the same time. They would tell all the nodes they were connected to, and whoever's best block propagated to over 50% of the network first would be the next one that got included. So you might have, if you were sort of waiting, you're pulling this transaction receipt to see if you got included in a block. You might get a false positive like, oh, it looks like you were included in block, 5 million or 5,000,001. And then you might see, oh, just kidding, it's still pending. So, there's this reordering that can happen based on the number of nodes that, kind of find the new best block. And whoever gets a majority will win. So ultimately, you might have a node, you tell your friend like, hey, I found this new best block, you should add it. And if they already have a block number, so if they already have block 5,000,001, they're going to tell you like, no, you're totally wrong. This is the block you should have. This is block 5,000,001. So it's kind of all these different nodes are negotiating with each other. And you do have, this is sort of why, I think in Bitcoin, you wait 6 confirmations to be sure that there won't be a reorder. And I think in Ethereum, since the block times are so much lower, I think you wait approximately like 20 to 100 block confirmations before you're sure there won't be a chain reorder.
Gotcha. So yeah, I think this is a good time to deep dive into the security aspect of this. Like, how does all this make the network, more secure? And I know that there's many different aspects of it. So, like, pick particular, aspects that you have seen or have read about or experienced.
Sure. So, the proof of work mechanism kind of makes the network secure, and that based on like the distributed hashing power. There isn't one party who's going to be able to sort of rewrite the chain based on what they want. So, ultimately, blockchains and proof of work are solving this. The first thing they solve is the double spend problem. So if I build up a transaction saying, I'm sending you, Kishore, 1 Ether, and if I write another transaction saying I'm also, sending Alice 1 Ether, I could submit them to 2 different nodes. They would start propagating out, but whichever transaction sort of reached majority consensus, like a bunch of the nodes in the network agreed, it would then throw out sort of the false ones. So I can never really achieve, this lie that I've tried to pay both of you the same Ether. So that's sort of, I think the main security feature that having all these nodes is that they sort of keep individuals honest, and then also, sort of prevent other people from kind of rewriting history, which I guess is sort of the same thing. They're kind of just keeping you honest and making sure you're sort of playing within their constraints.
Right. Gotcha. And then the individual nodes, you're saying that because this is all about consensus across the network, it is not too much of a concern that an individual node could be compromised.
Right. Yeah. So the idea here is that if an individual node is compromised, the general hashing power of the rest of the network is that it won't matter. And so that's sort of how the system was designed. So the original design, that Satoshi outlines in his white paper is that there will be bad actors in the system, and that's sort of why you have this consensus set up like this. So this is to acknowledging that bad actors will exist, and it would sort of won't matter as long as you have a bunch of different nodes participating in the network who sort of aren't controlled by one party.
Gotcha.
DigitalOcean is the easiest cloud platform to deploy, manage, and scale applications of any size, removing infrastructure friction and providing predictability so developers and their teams can deploy faster and focus on building software that customers love. With thousands of in-depth tutorials and an active community, we provide the support you need. DigitalOcean stands out of the crowd due to its simplicity and high performance with no billing surprises. Try DigitalOcean for free by getting a $100 infrastructure credit at do.co/SERadio.
And beyond consensus, I wanted to understand this whole concept of governance. So within Ethereum, or even before within Bitcoin, we've seen miners trying to basically define the path forward, or sometimes we've seen forking. So there's different ways to update the network, to update the nodes but there's also different ways to like achieve consensus amongst the human beings behind these mining nodes. So can you go down into like what does this mean, and then how does one update the the protocol itself?
Yeah, there's that. There's a couple things. It's one of the funny things. We talk a lot about immutable. The blockchain is immutable. There's no way we can change it. But ultimately, there's a bunch of humans on the other side of all the nodes maintaining the software. Maintaining the state that they're, the nodes are pointing to. So we do need to, rely on humans, and they're also a big part of the equation here. So there's as far as forking is concerned, when you want to, update the protocol, you might be doing something like changing the data structure in the block, or maybe adding a new property to a transaction or something like this. And there's two ways to do it. So you can a soft fork would be, well, we've just added a new property to a transaction maybe. And so old nodes, say they're running, version 5, and we're updating to version 6. And now we're going to allow this new data field that performs some feature. An old node might still be able to process the new transaction because it has everything it's looking for. It's still able to validate that it's good, but it doesn't perform any extra new feature that we've added. Whereas if you had version 6, you'd see this new field, and then you might do some extra work or do something else. So this is this idea of the soft fork, where old nodes can still participate, but they don't necessarily benefit or do anything that they're not acknowledging that the change happened. Whereas a hard fork, basically, if you had an old version of the software, your node's no longer going to be able to communicate with the network, and so you have to update. And this can be contentious. You sort of have to come to consensus as humans and say, okay, everybody, we're going to hard fork at midnight tomorrow. Make sure you update your node, otherwise you're going to stop. You're basically going to not be able to process blocks anymore, and you'll no longer be contributing to the network. So there's this interesting layer of sort of human consensus that has to happen before we can get the machines to come to consensus, which is definitely pretty interesting.
Sure. And the hard forks have also been in place as one of the mechanisms to maybe fix a security gap, or something that probably is causing, say, a particular hack to be then immediately fixed by doing a protocol update or a hard fork. Is that also right?
Yep, that's definitely one of the reasons that hard forks happen. One, there's been a couple examples of this in Ethereum. One of the more popular, or I think the most popular client is the Go implementation. And a couple years ago, at the Ethereum developer conference in Shanghai, the morning of the conference, which I think was timed pretty coincidentally. I think this was definitely happened on purpose. But basically, there was a memory leak for a certain type of transaction where you could, sort of cause the node to fail by submitting this specific type of transaction. So basically, the network was under a DDoS attack with these transactions that caused memory leaks, and everyone had to coordinate. There's a couple different. There's the Rust implementation made by Parity, and there's a few different implementations that people use. So basically, people were furiously trying to hotfix to and then implement this fork. So they sort of hotfix the bug, update all the software, release the new releases, and then kind of coordinate with everybody. Okay, everybody switch to this new version. We've fixed the memory leak. And so that was, interesting and exciting to say the least.
That's a very good example in even the, the world of software development and faster releases. If you think about it at a more open sourced, open governance model, this could be done with forking, with the community across the globe. Whereas we've seen problems releasing software just within a company, which has all the resources at its will. And and we still don't go to market quickly. So yeah, it's an interesting thing to see like how the governance of the community within an open source model, completely EIP and ERC driven, has moved towards this fast update, even though a lot of times it feels slow, just because as you mentioned earlier, the scalability and the other bigger changes to the protocol takes time.
Yeah, absolutely. It's very interesting to see, when everything's happened in this open environment. It's the attacks can be just as coordinated as the constructive software building and delivering. So it's definitely a sort of a new way to think about the software development process.
Great. So we covered the components of Ethereum, looked at Ethereum virtual machines. What is the overall definition of different components that an EVM is composed of, and then how do you actually interact with that? Let's go on to the way people develop apps for Ethereum. What are these mechanisms that people use to develop apps?
Sure. I'd say a lot of the tooling, luckily, can be pretty similar to things we're used to. So sort of like front end architecture for an application. You can kind of pick your flavor. If it's a iOS app or a web app or anything like that, it's going to be a pretty standard architecture. The one big difference, at least for Ethereum, where that's where most of my experience is, sort of developing and managing these smart contracts. So I'd say in the Ethereum ecosystem, probably the most used and popular tool for smart contract development and management is a tool called Truffle. And so this tool will kind of help you figure out how to like set up your tests and how to deploy to different networks. In Ethereum, there's a number of test networks that sort of simulate the live net. So there's actual nodes kind of mining and producing ether on these different networks. And so you're going to have your smart contract deployed to at least maybe like a local network that has super fast block times for you to do development. Then you might deploy to Rinkeby or one of these other test networks that has a slightly slower block times. It simulates the live net a little bit more. And then you'll also be deploying the app to the live net. And it is a little bit interesting because to interact with the smart contract once it's deployed, you kind of need to have this metadata file that kind of contains all the different function. It has some mappings between like the function names and what the smart contract actually looks like. So there are some considerations for sort of architecture considerations that are a little bit different than in general. But luckily a lot of the tooling is the same, and it's sort of just this keeping track of these files. They're called the ABI, or application binary interface. So you do have to keep these JSON files somewhere within the front end of the app, whether it's iOS or a web app. But everything else is somewhat standard, which is kind of nice. And I guess I would like to say Truffle is not the only tool for doing this. There's a project called Maker that's working on one of these tokens it's called a stable coin. So it's sort of supposed to be like a price stable, less volatile token. And they built a lot of their own tooling that I've heard really good things about. I think it's dap.tools or something like that. And yeah, there's a couple other sort of smart contract management and deployment tools.
Gotcha. That's pretty interesting view of the development ecosystem on Ethereum. So just to sum it up, you mentioned the overall architecture of an actual decentralized app would be comprised of the Ethereum protocol layer itself, the blockchain, which is decentralized, and then on top of that, you've got the smart contract ecosystem. So you have an application smart contract that is sitting within that, within that blockchain layer, but also that is the one that the developer has the access to in terms of modifying the application, putting in the business logic there. And then you can use the more famous frameworks for developing front end, APIs into the dApp. But there's a bit of like the ABI interface that you mentioned, which is the application binary interface that has to be known to the front end to be able to interact with the smart contract methods. Is that right?
Yeah, that's correct. And I guess one other thing to mention, yeah, that was a pretty good overview. So you have your front end layer that's pretty standard, and this is sort of also somehow hooked up, probably using one of these wallets to sort of sign and send transactions into the Ethereum network. And there's one of the common Solidity patterns is this concept of events, so event firing. One of the things that's still a little bit difficult is sort of historical state introspection of smart contracts. So you need some layer there that's sort of listening to Ethereum, and when these events are logged, they typically need to be stored somewhere else. So you kind of have the cycle of fire an event, like sign a message saying you want to do something. The smart contract's going to run, then it will fire an event, and you have some sort of service that's probably listening, and it might take that event and pop it into something more queryable than Ethereum. So you probably have some of the state's going to be copied into your backend, into something that's more queryable, like Postgres or something like that. So the UI can get some of these updates a little quicker than trying to figure them out directly from an Ethereum node itself.
Gotcha. Yeah, that's a key point. That we can use some of these events and state changes, and maybe index them over in a more queryable database. In terms of going into the details of smart contract itself, you mentioned Solidity is the language used today most commonly. Let's dive into what smart contracts are, and like maybe pick up a couple examples from real world. What is the kind of business logic that goes into smart contracts? I've also heard a lot of people saying that smart contracts could also be legal contracts. So I wanted to get into the details of different types of smart contracts that exist today, how real they are.
Sure. Yeah. So smart contracts, they're, as you mentioned, most commonly written in Solidity. And, they're really, at the end of the day, they're kind of just code that's, stored in the blockchain that anyone can interact with. This is an interesting paradigm that we didn't really have before. I can't really go inspect all the code that's, in executable form that's on your private server. So this is a pretty interesting new paradigm. And the way they're being used, since you can sort of, code arbitrary things into your smart contract, there's a lot of emphasis on sort of standards around, just what's the goal of this smart contract. And I think that's one of the things that the Ethereum community has been really good at is, there's public discussion for various smart contract standards. So for example, many people are probably familiar with, what happened in 2017. There was this like insane ICO boom. People are just raising absurd sums of money super fast on the internet. And, part of that was sort of possible because of this really good ability to sort of standardize and come to agreement around what sort of API or smart contract would have. So in Ethereum, they have these, ERC, these like sort of GitHub issues for discussing and coming to conclusions around what kind of features you need in a smart contract. And so one of the most popular ones or more famous ones is ERC20. So this is sort of the simple token smart contract. And this is what allowed all these different tokens to like be generated and then also sort of interact with each other. So that's probably one of the most used smart contracts that's out there. Another more recent one that's been pretty interesting is the ERC721. So ERC20 is a fungible token, meaning there that one token is the same as any other token. So if you have a balance of one token, it's going to be the same. Like my balance of one token is the same as your balance of one token. Whereas ERC721 is a non-fungible token. And basically this just means that, as far as the data structure is concerned, the tokens the same. And so you might think of something like a house deed, where, my house deed has this similar data structure to your house deed. However, if your house deed says that you own the house by the water and mine says, I own the house by the freeway, those house deeds are not sort of exchangeable. They're not one for one. And so there's now a lot of interesting work. As you can imagine, there's the non-fungible token standard is really interesting, even for, like something you mentioned as far as like a legal contract, where like, house deed is a kind of a legal instrument. So there's a lot of work and kind of research into that space.
So you mentioned something like ERC, the Ethereum request for comments, and that's how a lot of the community gets around the consensus building on what the standards for different types of tokens would be. So ERC20 you mentioned earlier for the most standardized, across which a lot of ICOs have raised tokens, and then more recently the 721, right? There's also EIPs, which are more like the improvement proposals, and I guess they have a larger scope for the protocol or the Ethereum improvements that are going on. When coming back to the ERC20,
the EIP is more like protocol level changes. If there's, maybe I wanted to propose a solution for a superior solution for ordering transactions, or something kind of on the low level. A lot of the scaling is a very big topic in Ethereum right now. How are we going to achieve high throughput? What are we going to do with all this data? The blockchain's growing sort of exponentially. So like, how are we going to shard the data? Like, what is this going to look like? Proof of work is a pretty simple consensus mechanism. Proof of stake is a lot more sort of components to it. So those kind of protocol discussions happen in the EIPs, and then the ERC is more sort of application layer. Like if we want to write code that's, interoperable, sort of at the EVM layer, whereas the EIP is sort of protocol layer.
That's great to differentiate. Thanks a lot. And on the ERC side, you mentioned ERC20 as a standard token for which people are, defining their application tokens or even the ICOs. Can we get into a little bit of a detail on, say, an example of what ERC20 actually defines, and maybe even picking up on an example token that exists?
Sure. So there are kind of tons and tons of different ERC20 tokens, representing all sorts of various things. And it totally ranges. So people can just, one of the interesting things here is, you can just issue your own and sort of say it represents, kind of whatever you want. But one of the more interesting ones are, people are experimenting with using these tokens to sort of, pay for distributed storage, or, specific types of processing. So there's a project called Golem, not the Lord of the Rings, but so the Golem token, the idea there is that you could sort of turn on your computer and let other people perform computation tasks that you might not want to perform directly in the EVM. So I think Golem's starting with sort of video rendering, like animated video rendering. I think this is like pretty, I'm not an expert in this, but what they've discussed is that it's very computationally intensive, and it'd be pretty interesting if you could sort of submit a job to the network. People who are there offering their services would then render the video for you and send it back, and you might pay them in Golem tokens. So this is, example of an existing ERC20 token. I think they're not in production, but they do have a number of sort of like beta tools out there that you can use and kind of participate in this network. Gotcha.
That's a pretty good example of how these tokens are being used. You mentioned distributed storage. You mentioned Golem for the more computing aspect of it. And when I see that, I also try and compare that to how we use computing today. Right, we have a whole commoditized cloud out there, and we can use it for generic computing. Defining applications, running them, scaling them. And it's amazing how that is now done more decentralized with protocols like Golem.
Yeah, absolutely. I mean, I think it's interesting. Just like you mentioned, there are sort of some of these tools out there that are useful and they work very well today, but kind of like the decentralized, permissionless aspects are pretty interesting in that
Right.
providing different solutions.
Right. So let's get into the details of how to even write a smart contract. And I think we discussed a couple languages that were used. The most famous ones of them is Solidity. So what is this language like?
Sure. It definitely has its quirks, but it's kind of similar to maybe Go and JavaScript, maybe like a little bit mixed together. So it's sort of an object-oriented software architecture. You can inherit from other smart contracts. You can have a smart contract that's interacting with a separate one. You can sort of spawn, generate. You kind of have like this sort of factory architecture. You might have a smart contract that makes new smart contracts. But in general, anyone familiar with object-oriented programming is probably not going to have too much difficulty picking up Solidity.
And in general, like, what are the basic constructs that one would start with if doing like the 101 of Solidity?
Sure. So the sort of the hello world of a Solidity contract would be the simple storage contract. So one of the simplest things you can do is update state. So maybe you're just storing a number in the blockchain, and then you want to go query that number later. So this is kind of the classic hello world for Ethereum, is getting simple storage up and running. And if you were looking to get started, I'd say the Solidity docs are an okay place to kind of poke around. There's a couple different sort of like standards bodies out there working on sort of like audited, community vetted smart contracts. So if people want to look up the Zeppelin smart contracts, those are pretty good to get started with. They come with a number of things, so you could create your own token, do a couple of these sort of like boilerplate setup features. If you just wanted to get something going, kind of like playing around, that'd be a good place to start.
Gotcha. So that's about Solidity as a smart contract development language. Are there some examples that one would start with if new to Solidity, and look at some of the more complex type of smart contracts, in more specifically compared to a real world logic of why would someone do a smart contract, say for payments or for how we say removing the middleman in certain transactions?
Sure. Yeah. I mean, some of the sort of classic ones are like, smart contracts are really good as registries. If you wanted to sort of, and we talk about like an identity a little bit, but you can register various addresses that represent certain things. Another classic one is sort of the escrow smart contract. If I wanted to write a web app that sort of escrowed dollars, I don't really know exactly how I'd go about it. I might investigate, who knows, like Stripe or something like that. But it's sort of trivial in Solidity, which is pretty interesting. So, I'd probably poke around with check out the escrow smart contract. Another pretty interesting one is sort of playing around with the multi-sig smart contracts, an interesting one. And you can combine the two, sort of have a multi-sig escrow smart contract. Some of those are probably good places to get started and kind of understanding sort of what you can do with the Solidity language.
Gotcha. That's pretty good examples of how we can begin with, like, looking at some real world smart contracts. And I'll definitely put some links out there in the show notes, just so that audience can also look at some of the basic smart contracts. So John, now that we've covered Solidity and different types of smart contracts, and also the fact that there are token standards, what is the in a gist, like, what is the Ethereum application for someone new that is coming into the ecosystem?
Sure. So at the end of the day, like dApps, they're not totally different than, we mentioned they're not totally different than sort of existing app architecture. But the interesting piece is that you can have sort of this permissionless, trustless layer that you couldn't really have before, So if you, we're building sort of a Craigslist app, distributed Craigslist, and you wanted to have, proof that somebody was actually interested in buying your couch and they weren't just going to flake on you the next day. You might have the ability for somebody to escrow funds sort of just built straight into the app. And this is kind of amazing in that you just need a few lines of solidity and the ability for somebody to sort of sign and transfer funds built straight into the app. But a lot of the UI developments is pretty much the sort of the same as anybody's used to. The difference there is you just now have, part of your app's API is going to be sort of interacting with this library called Web3. It's like the main way that people sort of sign messages. It's a JavaScript based tool. So it's, a lot of these apps are browser based, but it sort of allows people to do this message signing in the browser and then kind of, pull the wait and see, when their messages have been submitted. So as far as that level goes, that's pretty standard. Sort of the interesting part, the next part of the architecture that, is blockchain specific would be sort of, waiting to see if your message is going to be accepted by the network. So this is sort of an interesting problem that you don't typically have to deal with when building applications. Usually you're not waiting for your database to tell you that, something's happened, things are happening nearly instantaneously. And that's not quite the case with sort of existing blockchain architectures. So once messages are signed, you do need some sort of service layers that are giving your app feedback as to like, has the message, the transaction been processed yet? Did it get rejected for some reason? Then you have to kind of deal with that, probably not only in your backend, but also in sort of your the application layer of the dApp.
So I think in some part you also dived into the UI UX approaches for creating an Ethereum app, and you mentioned that there are certain principles in UX that might not be as similar to a traditional web app where you've got access to some really fast event databases and event streams, which Ethereum probably is not going to give you an instant query result. Any particular development or testing approaches that you have found useful for developing dApps?
I'd say the main sort of the main dApp test solution, or like one of the more common ones, is Truffle is quite common. So you're just writing lots of JavaScript tests that sort of mock out interaction with the dApp itself, and you'll actually the sort of a common pattern there is like, okay, have written up a reasonably sized Solidity smart contract. You can imagine you want to be pretty sure it's going to do what you think it's going to do, especially if your contract's escrowing funds or anything like that. And so, you'll write out a comprehensive test suite, and then you'll have, this setup where you'll kind of deploy a new smart contract, maybe seed it with some data, and then start, just going through unit tests for, unit tests and integration tests for what users could possibly be doing with the smart contract and making sure, you get the expected behavior.
Gotcha. In terms of testing, though, so you mentioned earlier that people use local blockchain for just quick development and iterating on, debugging their smart contracts.
Yeah.
And then there's also this concept of a test net. Can we go into like a life cycle itself of a dApp project? Like how does one get, these different stages of getting to the mainnet?
Gotcha. Sure. So, I guess the place you start is sort of getting a node up and running locally. And these will have, there's a couple different ones out there. They're going to have super fast block confirmation times. And the reason you can set this is you're the only node in the network. So you can, agree with yourself that the transactions are valid pretty quickly. So you'll have this set up and you'll be kind of configured to like deploy against this network and run some tests. So this would be, while you're sort of in development, adding new features, you can go ahead and write a test. TDD is still probably the most standard way smart contract development's done. So write a test, It can fail, implement the feature in your smart contract, get it to pass, and kind of iteratively go through this till your smart contract's kind of doing what you need it to be doing. And then the next step would be deploying to one of the other test networks that simulate what the live net's like. There's a couple of them. Rinkeby is a quite popular test net. Ropsten is also a quite popular test net. And so then after you are done testing against your local node, you might also deploy to that environment, run your test there. Once things look like they're passing, you're then going to go ahead and deploy to the mainnet. And sort of the interesting thing here is you would probably then not run your production smart contract. You're probably not going to run your test framework against it. So you might deploy to the mainnet, run some tests. The interesting thing though here to note is that you will be sort of paying per test, as we discussed earlier. You have to pay per computation. So if you have a very large comprehensive test suite, it's going to be quite expensive to test it on the mainnet.
Gotcha. That's pretty interesting as a problem in itself, that every time you do a transaction, be it testing or a real life production transaction on the mainnet, you'd probably pay gas. In terms of the local node, are there some tools that help you set up a local node without connecting to Ethereum?
Yeah, sure. So there's a whole bunch of different tools out there. You can, I believe there's one called the JavaScript one. It's called Ganache. Kind of goes with that smart contract tool Truffle. There's a tool Strato that's pretty easy to get up and running locally. You can just install some Docker containers and sort of start iteratively building your smart contracts. There's another sort of hosted solution called Infura that will let you test things. I think both Azure and Amazon also offer sort of blockchain nodes that are pretty easy to spin up and start going. And I think they have you can run sort of test environments, or if you wanted to run like a live net environment, you can also run that.
Gotcha. And then when you are actually moving code from local to testnet, is there a setup that is explicitly required to get your application some funds to run on the testnet?
Yep, there definitely are. So there's a number of different, I guess there's this concept of a faucet. So, on the testnets, your local node might have just a totally open faucet. You might have, when you sort of turn the blockchain on, there's this idea of the Genesis block. And so you can kind of configure some of the properties of your blockchain in that file. And so for testing, you might have this faucet that, when the blockchain turns on, there's one account with an enormous amount of ether. You can kind of use that to run all your tests. Then on the, some of those more public test nets like Rinkeby or Ropsten, they have publicly available faucets that you can sort of send, ask for small amounts of ether to kind of run your tests and stuff like that.
Gotcha. And looking at the smart contracts that we discussed in the development tooling that exists, let's just come back to the mainnet itself. Like how many of these smart contracts that we've seen in the ecosystem over the past couple of years have actually made it to the mainnet, and then within those that have been there on the live net, what have become of more like the usage of those smart contracts. So I'm trying to get to a point where we have seen a lot of smart contracts in development, but how many of them have actually gotten to the production grade?
Yeah, so I'd say more of them have not quite made it to the live net than have, but there's quite a few that are out there in the wild. A shameless plug here, but the product I work on is a blockchain-based art collecting platform called Super Rare. So there's which incorporates kind of like a marketplace. And there's, a number of these kind of, the gaming ones are also pretty popular. CryptoKitties, they kind of pioneered the ERC2021 smart contract architecture. So there's a bunch of these sort of non-fungible token applications that are being put out and being used in production. As I mentioned, the Uport identity solutions now on the mainnet. There's a project called MetaX that runs a sort of online advertising registry. And I think after about a year of sort of like architecting and testing, they're now in production on the LiveNet. So that's pretty exciting. And that's they're using an architecture that I think we haven't talked about yet called a token curated registry. Anybody who's interested in smart contract architecture probably be interested in reading up on TCRs, as they're called. So yeah, I'd say probably the most common things that are sort of in production on the LiveNet are sort of token smart contracts. There's a number of various exchanges for these tokens. Token curated registries are also quite popular. And then sort of identity solutions would be, I don't know, I guess the three sort of types of kind of common smart contracts that are out there.
That's great. And thanks for mentioning TCRs. I definitely include that in the notes. So now that these exist in the wild and people are using them, what have you seen of the service providers coming into this space to help, develop, test, and maybe even, operationalize some of the production-ready applications into the Ethereum ecosystem?
Sure. I think as we mentioned, both Azure and Amazon offer kind of boilerplate templates to get nodes up and running pretty quickly. As far as like tooling and stuff, Truffle is quite popular. There's some sort of comprehensive test, so like depending on how, into the nitty gritty you want to get, if you just want something, off the shelf that you can kind of turn on, there's, Azure offers some pretty good tooling around that. I mentioned Strato and some of these other sort of blockchains that you can kind of just like turn on instantly and then have, your setup kind of ready to go with, some of the key management and things like that. Infura is also, a really popular one, that's quite heavily used. They also support IPFS, which is interesting if you want to kind of play around with some of the distributed file storage properties.
Gotcha. In terms of the the smart contract testing itself, is there a way to reduce the risk of these security bugs that we have seen over the last couple of years? Because we play with funds and there's a bunch of things that are always dealing with live ether on the mainnet. How would one, as a smart contract developer, go about securing or maybe even pen testing some of that?
Yeah, sure. So, one of the more common ways is, a lot of this development is happening on GitHub. So there's sort of an auditing period. People also, it's pretty common practice to put up bug bounties for new smart contracts, especially if they're, doing something slightly less standard than some of the other things that are already out there. This is one of the more common ways to kind of incentivize people to help test your code. But I think it's one of the interesting challenges, if it's if you're doing something new and you haven't written a test case for something, there's not a whole lot of automated solutions. I think there are, people are working on, more formal verification, smart contract frameworks, and there's some interesting auditing tools out there. I think one's called QuantStamp that does some sort of automated sort of Solidity auditing. But it's still, I think that area is still something that is, in active development.
Gotcha. And between like the open source and more off the shelf, services that you mentioned earlier that are available on, major cloud providers, you're saying that a lot of the ecosystem still thrives on open source.
Yeah, it's definitely very open source driven, kind of in the ethos of the ecosystem.
Gotcha. That was also one of the most beautiful aspects of Ethereum in general itself, that, if you look at the ecosystem that has evolved so far, everything, including development, governance, the protocol proposals are all happening in the open source. And that's what I think is also driving this community together. In some sense, there's nothing hidden when it comes to, the changes that are coming live on the mainnet and how much time it has taken to actually vet those changes. Just picking on that adoption curve, though, there's definitely a lot of speculation around where the P2P aspect of this is coming, right? The peer-to-peer, removing the intermediary, getting things decentralized. But there's also obviously a net new, wave of applications that are coming up, like CryptoKitties, for example, right? Going back to your experience as a founder, like as a developer on Ethereum, and as a product manager earlier on, what have you seen as maybe some of the learnings in architectural patterns that have evolved? And then I wanted to like do a deep dive on just the way Pixura and Super Rare came about.
Yeah, I'd say just, one of the bigger learnings that sort of everybody is experienced in the space is that you want to leverage what blockchains are good at when they're good at what you're doing. And if it's not ideal for what you're trying to do, then that's a pretty clear sign you probably do not want to be, putting that part of your application into the blockchain. As we discussed, Solidity is an evolving language. It's being used in production, but it's still early days with a lot of these projects. And I'd say the best smart contracts are small and easy to read, audited. You don't want to be especially when you are dealing with funds. You don't want a huge, complicated smart contract that's going to have some critical flaws in it. So sort of just as little as you can write into the smart contract is a good place to be. So just to be mindful of that when you are developing. I'd say that's one of the biggest lessons that that I've learned.
Gotcha. In all the architectures that we are seeing evolving right now in the decentralized space, can you cover some of the most important ones that you have been, maybe looking at, involved in, or even the ones that interest you the most across different domains?
One thing that's come up a lot, in this conversation and just in general as the space is the, sort of the different architectures around identity. I think there's a few, identity is, at least in Ethereum, it's in sort of the smart contract layer. So there's a number of ERC proposals out there for different identity solutions. And so, yeah, there's still a lot of conversation happening. If anybody's interested, you can go sort of check them out on GitHub, which is pretty interesting. But I think identity is one of the interesting ones just because the sort of like key recovery, what happens if your keys get stolen. There's a lot of things to think about. So that's probably one of the more complicated architectural patterns out there. In finance, there's a ton of work. People are talking a lot about security tokens and, what does this mean? There's an interesting project called Pangea that's, sort of tokenizing shares of real estate. So if you wanted to add some liquidity to the value in your house, you could tokenize it and let investors trade it on the free market. So I think this is an interesting pattern, sort of taking existing, legal securities and then moving part of them onto the blockchain. So I think we'll see a lot more of that. And that's kind of an interesting space to watch. There's a lot of work happening in the healthcare space. I think some of the the majority of what I've seen is sort of around access to data, so data ownership. So it's pretty closely related to, the work that's being done with identity. Some of the differences here being, like there might be certain cases where you wanted a doctor to have access to data and maybe, a patient might not be conscious to like grant the access. So, there's some interesting use cases there and things to be sorted out. So there's a pretty active development though in that space. Is a number of different healthcare projects. And as I mentioned, one of the ones that's close to my heart is sort of, in the art space. It's pretty interesting to think about, art on the internet, how does this work? But, a lot of what we've been doing with Super Rare and Pixura is sort of digging into the, non-fungible token use case and seeing how we can apply it to, the creation of art in an online manner, to the collection of art online, experimenting with sort of what does this look like.
And that's pretty interesting space because it is digital native. You mentioned it's creation of art itself in an online manner. Can you dig a little bit deeper into how, like, what is Super Rare and like what is the, the value prop? What are you guys trying to like solve?
Sure. In a nutshell, Super Rare is a place for, artists and creators who are, whose work is digitally native to sort of, register their work online, and then also, have a way for sort of collectors to interact with it. It's interesting to think about. So, now we have a lot of these decentralized tools. They also have tools for like value transfers. So basically, we're letting artists create their own tokens that represent specific pieces of work, and then they can, they can sort of just have these, these are new tokens that sort of sit in your wallet, and the artists can, they could just upload them if they want to just have their work sitting there, or they can offer it up for sale. And, one of the fun things we've been playing around with at Super Rare is like thinking about like, okay, so you have, in art, there's this concept of the primary market and then secondary markets. And so we spent a lot of time thinking about that. And we're like, okay, it'd be really interesting if for secondary market trades, you could pay royalties to the original creator of the work, sort of as like, a thank you, especially if, you bought something when an artist was, not very well known. And then later on, if the work's appreciated quite a lot in value, it'd be pretty cool to, sort of pay tribute or pay royalties to the original creator. So currently on Super Rare, the artists get, the full portion of the sale on the primary market. And then in secondary markets, they also get a sort of royalty cut of the exchange fee.
I see. That's pretty interesting on how you deal with both the primary and the secondary market aspect of this. And once the original art has been sold, you're saying that a new transaction beyond that point would still have royalties to the main artist.
Right, that's correct. So in the just in the smart contract, when you call sort of like if the work's up for sale and you're interacting with the smart contract saying you want to buy it, if it's after the first time the work's sold, the smart contract will do a little bit of math and kind of pay the appropriate parties their share. So it's a simple feature in the smart contract, but it's a pretty interesting use case in my mind. It sort of opens up a whole new way to interact with the work, and think about like paying attribution to the creators and things like that.
Great. So what's your go-to reference for all things Ethereum and like more generally in the blockchain space? Where do you get most of your Ethereum reading references from?
For Ethereum specific things, I'd say my go-to references are probably the Ethereum subreddit and then also the Ethereum dev subreddit. Those are, two of my favorites. And, the Ethereum subreddit's, sort of just general state of affairs. And the dev one's pretty good for, just looking at new tools or experimental projects that have come out. Or sort of just like blockchain ecosystem things in general, I'd say Laura Shin's Unchained podcast is one of my go-tos. That's a really good one. I definitely recommend everybody check that out. And then for a pretty good overview newsletter, there's a newsletter called Token Economy. That's one of my favorites. So I'd say if you're paying attention to those three, you're probably reasonably up to date.
And by yourself, do you blog or write something on Medium, or do you have any favorite links that you'd like to add onto the notes?
Sure. So yeah, you can find I probably write the most under Super Rare on Medium. So if you want to go ahead and just follow Super Rare on Twitter and follow us on Medium. We try to write maybe once a week or so about just what we're doing. It's a mix of sort of on the business side of things or also just sort of the architecture and technical side of things.
Great. And how do people reach out to you? Any Twitter handle?
Sure. Yep. So you can go ahead and reach out to me on Twitter at Gnarzly. It's a GNARZLY.
Cool. I'll include that in the notes. John, so great to have you here on the show. Thanks a lot for spending some time, doing a general overview of the ecosystem and deep dives on smart contracts and generally these examples that you presented on what kind of smart contracts have come about in the mainnet so far. Again, thanks a lot for sharing this.
Sure thing. And thanks so much for having me, Kishore. Really appreciate it.
Thanks. This was Kishore Bhatia for Software Engineering Radio. Thanks.
DigitalOcean is the easiest cloud platform to deploy, manage, and scale applications of any size, removing infrastructure friction and providing predictability so developers and their teams can deploy faster and focus on building software that customers love. With thousands of in-depth tutorials and an active community, we provide the support you need. DigitalOcean stands out of the crowd due to its simplicity and high performance with no billing surprises. Try DigitalOcean for free by getting a $100 infrastructure credit at do.co/SE-radio. Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.